Runner, that's just weird.
You're just like, wow, my ankles are done.
It's circular and 200 meters. That's just weird.
It is.
200 pi meters.
Okay, so we have the circular track, right? And the friend is 200 meters from the center of the track. So if this is the center right here, the friend is going to be right about here. So we know that this right here, and we can label this. We'll call that, I don't know, C, A, and, I don't know, F for friend. Is that good? And we'll say that this runner, call that R, that's the runner. So we'll put all these line segments in. And we know that CR is what? 100. And we know that CA is 100. And we know that CF is 200. Correct.
And we know that RF is...
We don't know anything about R. Oh, at a specific moment, it is 200.
Yeah.
But every time it changes. RF changes. But CA is constant, CR is constant, and so is CF. I'm just labeling the constants here. Okay. Just the constants. That's it. Okay. Yeah. So the person's running around the track at what? 7 meters per second. That's correct. Okay. We want... What do we want?
We want the speed that...
How fast? No. How fast is the distance between the friends changing when the distance between them is 200 meters? So which rate of change do we want? Yeah. Yeah, so we want drf dt, right? When what?
When
RF is 200. So we want drf dt when R is 200. So we need to relate what and what?
We need to relate
X and...
RF is 200 at that specific moment, yes, but we want the change in RF. Sorry, not when. When RF. Yeah. When RF is 200, because look, when the distance between them is 200. We want to relate what?
Time and the distance between the
we want to relate RF and
where the runner is on the track to where the friend is to the runner.
We want to relate RF to what?
RC.
They've given us a value that we have not written down. CR is 100, they tell us that CA is 100 and CF is 200, but was one thing we haven't written yet. What do we AF is 100, that's correct. In the question, it gives us a number that we haven't given a variable name yet. Okay, there's only 3 numbers in the entire question. 2 of them are written down already. Which one have we not labeled?
The distance between R and A.
No. Okay, we have the 100 written down. We have the 200 written down. What do we not have written down?
7 meters per second.
We do have it written down, but we don't have it labeled to anything. What does that equal? 7 meters per second is what?
The rate.
Of what?
The runner.
In terms of a circle, what is that? 7 meters per second is d of something. The rate of change of what?
The circumference.
Yeah, the rate of change of
the arc length?
Arc length.
Okay. I had a feeling that...
Is that 7 meters per second on a triangle anywhere? No, the 7 meters per second is not the rate of change of the side length. It's the rate of change of the arc length. It's not the rate of change of the angle. It is the rate of change of the arc length. That is correct. So how do we link the two? Any ideas? Looking at our triangle right here, what can we say? We can say that RF squared equals what? 100 squared plus 200 squared, and I don't know why I put the parentheses there, minus 2 times 100 times 200 cosine theta. That's correct. So does that relate RF and theta?
Yep.
Absolutely. So we've related RF and theta, but that's not quite what we want. We want to relate RF and DAR dt, right? The rate of change of arc length. Do we have rate of change of angle? No, we have rate of change of arc length. Ready? Say it with me. 1, 2, 3. We have rate of change of arc length. we have something that relates RF, the length of RF, to the rate of change of the angle. What's the name of the angle? Theta. So we're relating RF and theta. We really want to relate RF and
Arc length.
arc length. So at this point, what do we really want right now? We want to relate what and what? Yes, we want theta and arc length. Exactly. So on a circle, if I have a circle like this, if I have a circle, sorry, and it's being a little glitchy, that's just how it works. That's theta, and this represents arc length. What do we call this? We'll call this, sure, AR, just to be, that's AR. How do we relate the two? Just to summarize what we have something that relates RF to theta, and we have something that relates theta to what? AR, right? What could we do at this point? Yeah, put that equation in for theta. So what do we have here? Let's take this and bring it down here. So we have that. So we take this and we plug in. We could differentiate twice, but instead let's just plug it in. What do we end up with? We end up with RF squared is equal to, we can just make 100 squared plus 200 squared minus 4 times 100 squared. Is that correct? Yeah. Cosine of what?
1 over R RF.
1 over R times what?
RF. AR.
AR. What is R? R is 100, right? So what could we say instead? Yes. Exactly. AR over 100, or 1 over, yeah, that's fine. Like that. Exactly. Very good. So now what do we have? We have something that relates RF and AR. What do we do now? Differentiate with respect to what?
Time.
WRT is with respect to. Guys, that means with respect to what? Time. Exactly. So if we differentiate this with respect to time, a lot of things go away. What happens to the left-hand side? What does it turn into? 2 RF to the what power? 1 times what?
DRF.
DRF dt equals 0 plus 0 plus, oh, minus what?
Minus.
Actually plus, because
Plus
400
Yeah.
sine of AR over 100 times what? 1 over what? Because you need to do the chain rule, right? What's the derivative of cosine? Negative sine. So that's why it became plus 400. So what does this become? 2 RF DRD. Sorry, I need the rest of that, right? DRF. Yes, I make a mistake? Because, what? Because I took a 2 out of there and made it.
So where did the
4 times 100 squared.
Oh, 4 times 100 squared. I'm sorry. Yes, you're absolutely right. 4 times, it stays outside. 100 squared. Sorry. Yes. Is that okay? Thank you. Equals, and it becomes 400, right? Because the hundreds cancel. Sine of AR over 100. Oh, it's 100. It's 1 over 100. What? D AR. We need that, right? Times
I was
what?
wondering what that
Yeah,
meant.
it's like we kind of need that, right? That's kind of the whole purpose of this. Correct? So what does this simplify to? Well, oh, the hundred's gone. It becomes 200. But we want what? Let's go back to what we wrote down. What we wanted at the beginning of this, right? What do we want? We want DRF dt. We want DRF dt. So we need to fill in everything else. What is RF? What?
200 at that point in time.
2 times 200 at that specific point in time. You're absolutely correct. If that was static from the beginning, what would the derivative of a static number be?
0.
Exactly. Equals 400 times, well, we don't need the parentheses there, sine of AR over 100 times DA. Oh, what's DAR dt? 7 meters per second, exactly, right? So what's the last thing we need to fill in here? What's the last thing we need to replace?
Arc length.
Arc length.
The arc length. So we need what? We need
The arc length.
AR when what?
RF is 200.
When RF is 200. Find that for me. It is in meters per second. Now let's see. Let's check reality. Does that match reality?
Yeah.
Should it be about that?
Does the track match reality?
No, the track doesn't. But the point is that number within the norms of reality?
Yeah.
You would expect something about 7 because he's almost kind of running straight away from his friend, but not quite.
Yeah.
Not quite running straight away. So since he's not running quite straight away, it should be a little less than. There's no way for him to run faster than 7 meters a second away, because if he was running directly away, it would be 7 exactly. But he's not quite. Now here's the deal. Let's just review what we did here. We related RF and theta, and then we related theta and AR, and then that allowed us to connect RF and AR, which allowed us to then differentiate and get a relationship between the rate of change of RF and the rate of change of AR. The rest was just algebra.
Oh, that's right.
This is how much work it took in order to do this question. Summarized, even in the book, it's like almost a third of a page, which means this is like a full page for you. Meaning on 22, or one of those other hard ones like the prism problem right there, do you expect it to fit inside like 2 inches of work?
Nope.
Please do not. It really is a disservice to you if you label the questions first and then try to fill it in. Like I see kids do this, 1, 22, 37, and then they try to fit the entire question into like 2 inches of work. Please don't do that. Please don't do that. Please don't do that. Please don't do that.
This track is going to run.
So what do they label it? Hey, we labeled it like that. But then, hey, what do they immediately use? Law of cosines. Hey, look at that. It, for some reason, didn't keep the right shape. Let's do this instead. There we go. It used law of cosines. That's nice. So they use L. Instead of using R, they use L. So they did this, right? Yay! They differentiate implicitly. So they got a relationship between the length, which is what we did, and the d theta dt. Then, what did they use? Now, if d is the distance around the circle, they know that, oh, they did the exact same thing we did. They just did the slightly cleaner algebra. Did they end up with exactly the same thing we did? Yes, they ended up with exactly the same thing we did. I'll put that in.